because I got to be able to see what I'm doing too. So, all right. So we're going to hide calc, the first calc, using just regular old FU from 2000, whenever, 2. FU's hidden, and that's the calculator on my left, your right, just so we can keep stuff straight when I try to close things. We're going to put this one on my right, your left. We're going to use FU2. Now, I mentioned that there's a -PHNG option, which stands for process hide no GUI. We're not using that. It's hard enough to do this demo. PHNG bypasses everything except dark spy, as far as I know, still. But it's pretty iffy on us sometimes with locking and things like that because we really hose the system. So we're just going to go with PH and hope things work out. Oh, okay, VMware. All right, so both processes are hidden, and you can see they're running, and I'll just click on stuff so you know that they're both legitimately responding, and I haven't frozen them. All right, and just real quick so we can go over it. Every one of these drivers is loaded on the system already. I'll show you that they are, just so you believe me. Real quick, basic MDL flags is your SSDT index hook. MIGBot is your inline hook. ERP hook is what it is the file name. It is an ERP hook. It's 3 ERP hook, actually. Byte hook is a 1-byte hook in 4 NTOS kernel functions, or 3. System enter is a system enter hook, and then NDIS hook is deep door and some export address table functions. The other 2 drivers are not actually loaded. So, as I promised, it's just 2 files. Give me a second here, just so we can. Now I'm going to break in WinDBG. This is always the interesting part. All right. There's your 1 inline hook. Another inline hook. Another inline hook. Another inline hook. You see where I'm going with this. And those are the ones I can show you. I'll also show you the service descriptor table just so you know that that's legitimately hooked. So there's the index hook. We're going to start WinDBG back up. Let's really hold our breath here. All right, we good? Everyone can see? All right, so what I'm going to ask you to do is direct your attention to the folder above, because I'll scroll back up. You're going to see a file dropped there and deleted. Watch the task manager as well. You'll see something spawned. It won't be in any language you recognize, nor I recognize, actually. So real quick, your scan options. One of the components of RAID is why waste time scanning everything when you know what you're looking for? Default is scan. Obviously, that's what I'm going to run. I offer scan processes, which just scans processes. Scan kernel just scans the kernel. Scan hooks just scans for hooks, but that includes userland and kernel mode. Scan all scans everything. It's pretty basic. And then you have the log option, which will log to a file, randomly create random file name in the current directory. This is just because the console output is a little heavy to read sometimes, and if you're on a pretty bad system, you're going to be hurting reading it. So it's just another option, and you can send it to someone to look at if you don't know what you're doing. Don't send it to me, please. So let's do this. All right, this is for my own protection. If there's something wrong and you don't agree to it, don't run it. So I agree to it, of course, my own system. 8 products, 253 hooks. 24 hooks found. Here we go. Watch the there's the file. It's in the task manager. It's running.
We just spawned a process from the driver. RAID runs completely as a driver.
So you just saw it work successfully, and that happens every time. All right, so yes. So what we're going to show you now is the dumping process functionality. And we might take a question because it does take its time doing this. Keep your eye on the folder. If we can get one question. Anyone have one question? Or no questions, that's fine too. Okay, we'll just wait then.
So with the dumping, what that allows you to do is take it back For forensic analysis, you can slap it into IDA Pro and other reverse engineering tools and determine, you may know that it was there and it was hidden, but now what in the world was this thing doing? And you're really going to need a human engineer to probably try to figure out what its intent was.
So as you can see, it's only dumped 2 of the DLLs from the address space. Like I said, this isn't going out in the public version because of reasons like that. The file size is also a little off. The page rounds up, so the file might not be aligned at the end of a page, and we might dump extra bytes that the executor won't recognize. And Windows has this little thing where if the file size is bigger than the size of the image value in the PE header, it's considered not a valid Windows process. So that's just something. And this is FU2. We are not going to do anything. FU2 nukes the process ID just for the fun of it. It is annoying. I don't know why I did that. That was pretty stupid of me. But so you can see it does nuke the process ID. So that one was, we're going to do nothing with that. Now you have your hook menu. You can restore just this hook and continue on. You can restore all the hooks. Saves a lot of time. You can ignore this hook, just continue on. You can ignore this type of hook. And this is a feature that you should use if you have a firewall we don't support and you're getting hit with like 56 hook functions. They're going to all be of the same type. You just ignore them all and continue on. You can only display, or you can dump the file containing the hook, which we're not going to do. But we will restore all the hooks. Now notice the file was deleted. It's off the system. And now we'll scroll up and we'll just go through some of the outputs so you can see what's up. And I am going to put in new line characters. I'm not allergic to them. I just didn't put them in earlier. So as you can see, the inline hooks are all there. They've been detected and restored. The ERP hooks, which is what Jamie was talking about, for hiding ports, are all there. They haven't been restored. The EAT hooks have been restored. And this is the deep door, the NDIS protocol characteristics. It tells you that it's been modified, like the send complete handler has been modified, and it's pointing to the NDIS hook. So it's picking up deep door and things like that, and I'm not sure how it will fare against the talk coming up, but we'll find out, and we can make modifications if we need to. So that's pretty much it. We can do another run if you want to see how much time do we have left. Yeah, we can do another one real quick and show you the relinking. I've had that thought. That's as far as it's gone. Do apologize.
Y'all realize it's supposed to last until 12:30, right? Yeah. Okay. You ran it from a folder, and that folder didn't reside on that.
Yeah. So now we have the processes, and what I'm going to show you is watch Task Manager. It is now appeared back in Task Manager.
Calc just got relinked.
So it's decom in reverse, FU essentially, in reverse, which is a neat little trick we use. And then now it's offering us the, well, no, we're not going to dump the file. And that was the scan process only option. So, and then real quick, just for everyone's own benefit, you notice the jumps are now gone. All of them. And you'll also notice that the query system information has been restored. Yeah, it's been restored. So essentially everything I said it did, and it always happens like that. Do we have any questions?
You have to be able to install a driver. Yeah.
You're taking the jumps back out, right, or doing the relinking so everything's running smoothly. How are you doing that on a signature-based approach, or?
You're asking how are we doing the relinking?
Yeah, because I would think you have to know every process.
No, it's actually one line of code. The question was how are we doing the relinking, and the answer is quite simple. Active process linked is a list entry structure, and so essentially we're just removing ourselves. There's a function or macro in the DDK that's called insert list at tail, And all we need is the e-process and the system e-process, which we can obtain by 2 API calls. And we just add it back in. So it just gets added to the end of the list and reappears. It was sort of shockingly simple. And then the well, I start at the beginning of the function and I go down however many bytes I've decided. Essentially, because I'm able to find the KI service table from disk using, as I said, 90210's method, I know where the function is locally, and I just start there, and I start in memory, and I just back and forth, and it's, it's pretty easy, and it's a legitimate way to do it. And it just depends how deep you want to go, and you just make sure you line up on how deep. Well, I mean, one could make the, well, this doesn't run on Mac, but one can make the assumption that Joanna's about to hose us. It depends, and like I said, it's a cat and mouse game. I'm looking forward to Joanna's talk. It's the last one, but I encourage you all to stay and see it. As far as I know, everything I ran it against, it worked fine. Shadow Walker, you can get past it. I know, I mean, we know how to with Shadow Walker, but it still picks up the IDT hooks, so you'll know something's up. UAY, it picks up because of the NDIS hook detection. So I mean, right now it's pretty good, but as we get into the more virtualized technology, we're going to see greater problems and things like that. Oh, sorry. Well, the problem with restoring ERP hooks is we have to know what the original address value was, and we don't right now. No, and it's not in the works either. That's not. I'm sorry. Yeah. I'm sorry? No, I said it doesn't recognize rootkits that aren't hiding themselves, but nothing will. Essentially, if a rootkit's not hiding itself, it's in plain sight, and all you need is, I recommend, OSR has a program called Device Tree, and it'll list all the drivers that are installed in your system. You'll see it. Yeah, when I said that, I was saying that there's some people have taken the stance that if I don't hide my driver, there's nothing to find, and that's true, but it's also easy. If the administrator knows what they're doing, they can go through with Device Tree and say that device doesn't look familiar. Any other questions? Or,
Do you have a problem with other protection software? Whether you had a problem with other protection software, somebody was your rootkit?
well, we don't have any hooks, so no one thought we were rootkits. Kaspersky messes with the Windows like I've never seen before, so that was quite an experience getting RAID to work with it. But RAID does work happily along with Kaspersky now, along with all the other firewalls you saw. It runs fine. So yeah, I mean, we don't do any hooking, so we've not had that problem. I don't know if the antivirus will take the stance that this tool will be a problem, and they'll say, I don't know, they're weird like that. So.
And a lot of the protection software tries to block certain API calls. RAID is bleeding edge, which means we're using pretty much all the rootkit technology that's in the 2nd generation advanced digital weaponry class that taught on Monday and Tuesday. We use that for good purposes. So it's very bleeding edge.
Yeah, if you dump this in IDA and look at what we're calling, you're not going to see too many API calls. We try to avoid them like the plague, just because I don't trust API calls. And like Bill said, we're on a system that's potentially owned, so anything we get back could be tainted. So we take the stance that the less we get back is better. So we try to avoid relying on any information. We make very few API